All right, so why do we need, so first of all, okay, we're concerned about the binary and hexadecimal. IP addresses use binary numbers, okay, which are converted to hexadecimal, sorry, which are converted to decimal only so they can be remember or read easily, okay? But your computer always convert your decimal number to binary number. This is called ending process, okay? I don't know if you guys have learned it. So it's just, so the way it works is whenever you're accessing another computer on a network, the TCP/IP, okay, the IP protocol, the software, what it does is it look at your actually subnet mask and the IP address, and it's convert into binary, okay, and then the source address, and it also convert the destination address into binary, and then it performs ending process to determine either it's in the same network or it's in a remote network. If it's in a remote network, where does it sends the packet to the default gateway, okay? And if it's in the same network, it sends the packet to its destination. So the conversion takes place on your computer by the TCP/IP protocol itself, or you guys know that TCP/IP is a software. So that's what the software does. So the binary are actually the real numbers that are used to forward packets on the network. Okay. Now, in real life, you will never have to convert binary to decimal or decimal to binary or binary to hexadecimal, okay? Manually. There's no reason. What we have, there are a lot of online calculators. Windows calculator became very advanced. I always use Windows calculator whenever I have to convert to do the conversion. So I encourage you, or not encourage you, I'll tell you to use Windows calculator, okay? So, okay, so these are binary numbers calculated into, sorry, decimal number calculated into binary, and you can see what a mess, okay? Imagine remembering, you have to remember these numbers. So, okay, what is the subnet mask in what this 24 represent? Can anybody tell me?
So are you presenting?
Oh, I'm not. Yeah, I am present. Okay, hold on. Oh, I was presenting.
24 is the subnet mask.
Okay, so here, what does this represent? 24, Yuri?
The subnet mask.
Okay, but exactly, it represents the subnet mask. So what does 24 means? Yeah,
Number of hosts.
eh?
Number of hosts.
No, it's not number of hosts.
It separates the network address from the address of the hosts. So the first 24 digits are reserved for the network, and the rest is.
Excellent. Exactly. So the first 24 are belong to the network. So the 3 octets, and the 8 networks are belong to the host. Okay, so that's what 24. So you see, it's all about binary numbers. Okay, so the 24 bits, and especially when you do the subnet mask, you take bits from the host ID and then add it to the network ID. Okay, so yeah, so that's what it means. So if you ever see like 24, what if so what is the subnet mask for this in decimal, Yuri?
It's 255, 255, 255.0.
Perfect. So if you see 16, it means what is the subnet mask? If you see 16, sorry.
2 times 50, 255, 255.00.
Perfect. So that's how you calculate. Even if you are subnetting. So let's say if you borrow 3 bits from the last octet, okay? So your subnet mask will consist of 27 bits and 27 bits, and the rest would be would belong to the host ID. So this is that's the significance of binary to, numbers to decimal. And how many bits are in one octet? How many bits are in one octet?
8 bits.
8 bits. Yes, exactly. So the total of 32 bits. Anyway, let's see this video.
In this video, I'm going to
So it's a small video. Let's see if we can find something useful here. Okay.
discuss binary to decimal conversion. But before I do this, I want to take a look at positional notation, or place values. I have the number 2168 here. If we look at the place values of the number 2168, we can see that the place values have the ones place, the tens place, the hundreds place, the thousands place, 10,000, 100,000, and million. These are the place values of the base 10 decimal number system.
Okay, so who's gonna tell me what 3 numbers are here? If you guys have done this. So we are missing 3 numbers here. Okay, let's move on.
You can see that we have the number 2 in the 1000s place. So we have 2 1000s. We have a 1 in the hundreds place for 100. We have 6 in the tens place for 60. And we have 8 in the ones place for 8. So effectively, we have 2 1000s, 1 100, 6 tens for 60, and 8 ones for 8. Now, when we're talking about the place values in the decimal number system, we're talking about the powers of 10. You can see that the ones place is the 10 to the 0. The tens place, 10 to the 1. The hundreds place, 10 to the 2, or 10 times 10, which is 100. The thousands place is the 10 to the 3, or 10 times 10 times 10, and so on and so forth. So you can see that the place values are based on powers of 10. If we look at the number 2168 then, in long form, we can see that effectively we have 2 1000s, 1 100, 6 tens, and 8 ones, and 2000 plus 100 plus 60 plus 8 totals 2168. This is the type of counting and addition that we learn as children. The decimal system is base 10. It's based on the fact that you have 1 powers of 10, but more importantly, you have 10 characters or 10 numerals in this counting system, from 0 all the way up to 9. So that means that in each place value, you can have anywhere from the number 0 up to the number 9. In other words, if I had the number 9168, I'd simply replace the 2 here with a 9, and now I have 9 1000s totaling 9000 in the 1000s place. So in any one of these place values, you can have the number 0 all the way up to 9. This is the base 10 decimal number system. If we consider binary and look at it in the same light as decimal, binary is a base 2 number system. There's only 2 characters, or 2 numbers, 0 and 1. So under the place values, we can only have zeros or ones. The place values go from 1, which is 2 to the 0, to 2, 2 to the 1, 4, 2 to the 2, 8, 2 to the 3, or 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16. That's 2 to the 4th power, place value of 16. The 32's place, the 64's place, and the 128's place. Notice that I extended the table to 8 place values. That's because 8 bits is an important grouping of numbers. 8 bits makes a byte in computer processing.
So you're muted.
Sorry. The position, yeah, because I mute the mic, so it stopped the echo. Okay, so the position is important when you're converting binary to decimal. So it starts from 128, goes all the way to 1, and then you just calculate them. Okay. So do you want me to continue this video, or you guys are okay?
So now I have the place values for essentially 8 bits. If I want to write the number 168 in binary, I just have to find the corresponding place values and plug in either a 1 or a 0. So I'll go to the 128th place and ask myself, do I need 128 to reach 168? Yes, I do. So I'll put a 1 there. Now, do I need a 64? I already have a 128. If I add 64, I would get 192 because 128 plus 64 is 192. So the answer is no, so I put a 0. I still have 128 now. Now, do I need a 32? 128 plus 32 is 160, so yes, I could use a 1 here. Now I have 160. Do I need a 16? No, that would make 176, which would go over my target number of 168. I'll put a 0 here. What about an 8? If I add an 8, I'll hit the number perfectly. 128 plus 32 plus 8 is 168. I'll follow this up with zeros in the 4's place, the 2's place, and the 1's place. And 168 in binary equals 101010000. I now have 128, I have 132, and I have 8. And 128 plus 32 plus 8 equals 168. If we go to the next slide, you can see now that I'm now charged with converting the number 01101101 to decimal. If I want to go the opposite.
Okay, so who knows how to do this? Tell me. How are we going to convert into this decimal? So what is the decimal of 01101101? Anybody?
I can do it if you want.
All right, go ahead, Masood.
64 plus 32.
Okay, so here, what are you going to put?
0.
Okay.
1, and the next one. Next one. Next 0. 1, 1, 0, 1.
Okay. All right. So what would be the decimal? How you will calculate the decimal value?
64 plus 32 plus 8 plus 4 plus 1.
And what is the number?
64 plus 32 is 96, and 104, 108, 109.
109?
Correct.
Yeah. 64 32.
Okay, hold on. Yeah, 109. Okay, perfect. So what you do is, okay, simply what you do, you just add all the ones. That's all. So you 0, 1, 1, 0, 1, 1. So this is how you calculate.
Opposite way and convert the.
Well, you convert binary to decimal or decimal to binary. Okay. So this is, well, explain it here. Position in number, calculate position value. All this here. This is what they're explaining. Okay. Anybody has any question or anybody has any problem with this, understanding this? All right. I take it as no. So this is how you convert decimal manually, decimal to binary and binary to decimal. So let's see if you do this quiz how well you do it. Don't cheat yourself. Don't use the calculator, okay? All right, so you start from 128 and goes to 1, 20, 128, 64, 32, 16, 8, 4, 2, 1, and just add all the ones, okay? That will give you the binary. That will give you the decimal value of the binary number, okay? All right, so do this activity binary game after IP version 4 addresses. You guys, everybody understand these addresses. So you have 4 octet, total 32 bit. And this is how, so actually your computer uses this number to find the destination, not this, actually this, and this is converted, okay? And this is called ending. Have you guys heard of ending process? It's going to come in the later chapter. Hexadecimal numbering system. Okay, so first of all, where hexadecimal numbers are used in networking? Anybody?
IPv6,
IP version 6. What else?
MAC address,
And the MAC address. A MAC address is actually the address of your network card, or the address that is burned onto your network card. That's why it's called hardware address. Okay, now you can change the MAC address with software these days, but actually this is just you're masking the real MAC address. The MAC address, real MAC address, cannot be changed because it's hardwired. Okay, now MAC address uses hexadecimal, and IP version 4 uses hexadecimal. Hexadecimal is base 16, right? So it's from 0 to 9, and then 11 to 16 is A, B, C, D, E, F. Okay. And uh, here, if you look at the topology of IP version 6 hexadecimal, so this is IP version 6 is actually 128-bit address, and this is also, these are called, they're divided into hexadect. Okay, in IP version 4 they're called octet, and in IP version 6 they're called hexadect. Okay, and later on, so they also use actually binary number that are converted into hexadecimal. And I don't know if you guys have covered this, but later on you will learn how to actually trim down your IP version 6 address, because it could be very long. And this is how you assign the IP version 6 address to devices. So in our lab, all our devices are capable of using IP version 6, because it also depends on software. Okay, some routers, older routers or switch, they are not able to recognize IP version 6 because their software is not updated. But in our lab, so later on you will also learn how to configure IP version 6 addresses. Okay, actually that would be part of exam of module 16, where you have to configure IP version 6 address on devices as well. Okay, how much you guys have learned about IP version 6? Have you ever configured IP version 6 address on devices?
I don't think so.
Don't think so. So that would be something new for you. So you will create in the lab, or you see even with the packet tracer, 100% IP version 6 network. And you will use ping command to ping IP version 6. So IP version 6 is the adoption is slow, because it's not the software has to be updated, okay, or completely modified. So it costs a lot of money, okay. It's not just the operate, any device that uses addresses need to be updated. That includes programs, softwares, switches, routers, intermediary devices, end devices, the cell phone, all kind of devices. So that costs a lot of money. That's why the convergence is a little bit slower. But those of you who are young, okay, still 20 or something, you will have to work with IP version 6 in a couple of years. You'll see, because IP version 4 has a lot of security holes, like a lot of security vulnerabilities. Okay, so that's one of the. So it's not just there are less IP version 4 addresses. That's not the only reason to migrate to IP version 6, but also there are security reasons and the speed. IP version 6 is faster than IP version 4, especially when you're using IP version 4 with network address translation. So it creates latency on the network. So if a network is 100% IP version 6 based, it also helps with the performance. So it's not just security, but also the performance. So let's see, let's play how big the video is. It's not long, 6-minute video. Let's see if you guys know anything from this.
Hexadecimal, or hex for short, is a base 16 number system. It uses 16 symbols, the numbers 0 to 9, as well as the letters A to F. It is based on powers of 16. If we follow the same procedure used for converting binary to decimal, we can write out the place values or positional notation for the hexadecimal number system as well. Here we can see the first 4 place values based on powers of 16. This is 16 to the power of 0 or 1. Any number to the power of 0 is 1. This is 16 to the power of 1 or 16. This is 16 to the power of 2 or 16 times 16, which equals 256. And this is 16 to the power of 3 or 16 times 16 times 16, which equals 4096. Let's look at the decimal and binary equivalents of each hex symbol. These are the decimal equivalents. Note that the hex symbol A is equal to decimal 10, hex B is equal to decimal 11, and so on until we get to hex F, which is equal to decimal 15. Here are the binary equivalents. Note that each hex symbol can be used to represent a 4-bit binary number. Given that 8 bits is a common binary grouping, we can represent an 8-bit binary number using just 2 hex symbols. In this first example, let's look at converting hex 2A to decimal. First, I'll write out the positional notation for the first 2 powers of 16, then insert the hex symbols below the corresponding place values, 2 under 16 and A under 1. Then I'll multiply each hex symbol by the place value that it's under and add the results together. So we get 2 times 16 plus A times 1. That gives us 2 times 16 plus 10, which is the decimal equivalent of A in hex, times 1, which gives us 32 plus 10, or 42 in decimal. Multiplying or dividing by 16 isn't always easy when doing hex to decimal conversions. Usually it's easier to convert the hexadecimal or decimal value to binary first, then convert the binary number to decimal or hexadecimal. Let's convert decimal 197 to hex. First, I'll begin by converting 197 to an 8-bit binary number. Here I've drawn out the first 8 place values of the binary number system. We need to find out what combination of these place values adds up to 197. I'll begin by writing 197 on the left side, and starting at the left, if the place value is equal to or less than this number, I'll put a 1 under it and subtract it, and if it's greater, I'll put a 0 under it and move to the next place value. Since I can subtract 128 from 197, I'll put a 1 under it and subtract it, and that gives me 69. I can subtract 64 from 69, so I'll place a 1 under that and subtract it. That gives me 5. 32 is too big, so I'll place a 0 under that. 16 is also too big, so that gets a 0. 8 is also too big. But when I get to 4, I can subtract that, so I put a 1 there, and I subtract it here. 2 is too much, so a 0 goes there, and 1 is just right, so I subtract it, and it results in a 0. Therefore, decimal 197 equals binary 110000101. Next, I'll convert the 8-bit binary number to decimal by first splitting it into two 4-bit binary numbers, and then I'll rewrite the first 4 binary place values above each half. So here I have 1, 2, 4, 8, and then repeated on the left 1, 2, 4, 8. Then I'll convert each half to decimal and then each decimal to its equivalent hex value. On the left side, we get 8 plus 4, which equals 12, and on the right side, we get 4 plus 1, which equals 5. If we convert those to hex, 12 decimal is the equivalent of C in hex, and 5 decimal is the equivalent of 5 in hex. Therefore, 197 in decimal is C5 in hex, or it can also be written with a 0x preceding it to indicate that what follows is written in hexadecimal. Lastly, let's look at converting from hex to decimal, but this time we'll convert to binary first instead of going straight to decimal like I did in the first example. I'll convert the hex 9F to decimal. First, convert each hex symbol to its 4-bit binary equivalent. I have hex 9, which is the same as decimal 9, and that gives me 1001. And then I have hex F, which is equivalent to decimal 15, and that gives me 1111 in binary. Next, I'll combine them into one 8-bit binary number. So here I have the first 8 place values in binary, and then I'll convert to decimal, and that gives me 128 plus 16 plus 8 plus 4 plus 2 plus 1, or 159 in decimal. There are often several ways to approach converting between number systems. You should use the one that works best for you.
You're muted, sir.
Hexadecimal, or hex for short, is a base 16 number system.
Sorry, so this is how you convert manually hexadecimal to decimal and decimal to hexadecimal. Okay. Now I used to when I teach in the class, I prefer using the whiteboard. It's easier to explain. Okay, since I don't have a whiteboard in my house, so guess what? I found a guy with the whiteboard on YouTube. All right. So here you'll see if you let me see.
There we go.
So this is the video. It explains how to convert
Right here, we're going to learn to convert
decimal to hexadecimal.
from decimal to hexadecimal. The first thing we need to
Manually,
know is to figure
okay?
out what hexadecimal is. We use it in relation to the decimal format. For the first 12 years of school, you learned decimal formatted numbers. You just didn't realize that. By 10th to, obviously, you get a little etymology, right?
Anyway, so just I can send you the link if you're really interested in finding out how to convert decimal to hexadecimal manually, right? This is interesting. This video is explain it well. Okay, it's only 5 minutes 45 seconds. Okay, and but I'm not gonna play it. Just watch it on your own. In my exams, I'm gonna let you use the calculator. Okay, so you can use the calculator. What is the So that's all the numbering system is. Okay, so I'm going to show you, for example, do you guys know how to use Windows calculator to
Yes.
I'm
Convert.
just going to show you those of you who don't. Okay, so for example, Windows calculator, voila. All right, so this guy, for example, here,
16, 9, and 5. So we're going to convert that from decimal.
so if you see, so manually, so you're converting
To
4,500
hexadecimal.
4,512 into hexadecimal, and it will take a lot of
Right,
steps.
the
You know, you
prerequisite.
have to subtract.
45,
If you're gonna
12,
watch in the
divided
video,
by 16. Let's see, we get 2, 32. Subtract.
you have to perform division like 4 or 5 times, right? So let's convert if we are using Windows calculator. $4,512. Okay. So you choose, so in Windows Advanced Calculator, you choose the programmer, okay? And in the programmer view, you can convert hex to decimal, decimal to octal. We don't use this, and decimal to binary. So 4,512 hexadecimal is 11A0, right? And binary is this. So any number you can choose if you want to convert, let's say decimal 250, sorry, decimal 256. What is the binary? This is the binary of 256. Okay, 255. Let's see, 255. All ones, which is a broadcast address. Okay, let's see, decimal 0. So it's 0. So especially when you're converting, when you're calculating subnets, you have to convert. You have to know how to convert decimal to binary and binary to decimal. So use the programmer. Okay, and yeah, that's all.